Alright, so now let's practice finding absolute extrema for a function on an interval. So f of x equals x cubed minus 6x squared. So, and we're looking at it on a closed interval -1 to 3. So keep in mind, in general, domain of this function would be -infinity to infinity. So it's continuous everywhere because it's a polynomial. So it's definitely continuous on -1 to 3. So now let's step 1, we need to find our critical numbers. So to do that, what do we need? We need our derivative, right? So let's find f prime of x. So f prime of x, 3x squared minus 12x. And let's go ahead, simplify that, factor out. So that's 3x times x minus 4. So we know in this case to find the critical numbers, two pieces, right? So f prime of x undefined. Well, it's never undefined, right? Why? Because f prime of x is a polynomial, so it is defined everywhere. So it's defined on -infinity to infinity. So then we need to find where f prime of x equals 0. Well, f prime of x we just said is 3x times x minus 4. Set that equal to 0, so that means 3x equals 0. So x equals 0. X minus 4 equals 0, so x equals 4. So our two critical numbers in this case, x equaling 0, x equaling 4. Now these are critical numbers for the entire function. But then we look, okay, we're restricted -1 to 3. So we look, 0 is in -1 to 3. 4 is not in -1 to 3. So we cross through it. We don't need it. You still got to show me it's a critical number, but we don't need it for this, for finding absolute extrema. So now step 2, we evaluate the function f at the endpoints and the critical numbers in the interval. Since we're only looking at the absolute extrema on the interval, it doesn't make sense to plug that critical number we found, a 4, in. So if you did that, you're just going to be doing extra work that you don't need to do. It's going to slow you down, make you take longer on the test, possibly not get it turned in on time, right? So you want to make sure that you're only evaluating the endpoints and the critical numbers in the interval. So we need to find f of 1, or sorry, f of -1. So f of -1 is -1 cubed minus 6 times -1 squared. And so when you evaluate that, you get -7. F of 3, so that's our other endpoint, so that's 3 cubed minus 6 times 3 squared, and that gives you -27. And our only critical number in the interval is f of 0, so 0 cubed minus 6 times 0 squared, which gives us 0. And so to find your absolute extrema, you're just looking for the largest and the smallest values of the function. So the largest and smallest y value. So in this case, -27 is our smallest y value. 0 is our largest y value. So what does that mean? So in this case, we have an absolute minimum at 3, -27. Yes, you got to write out the entire ordered pair. Think of it like your mailing address. You have to have the street address and the zip code, right? Or whatever you're mailing is not going to get there. So in this case, you got to have the x coordinate and the y coordinate, or you're not going to get to that point. So you got to give me both values, the x and the y. So absolute minimum is 3, -27. And then our absolute maximum is 0, 0. And that's all there is to finding absolute extrema. And so to be able to do this, you're going to have to be able to find derivatives of everything. So make sure you review your derivatives from test 2. Also make sure that you'll be able to simplify them and do the algebra and trig required to find the critical numbers, right? Hang in there though, you can do this, right? It's not that bad. All right, so then second one, f of x equals x squared over x minus 1 on the closed interval -3 to 0. So in general, our domain we know is -infinity to 1, union 1 to infinity. So then f prime of x now. So keep that domain in mind, right? Especially because in this case, doesn't apply because it's outside of here, but there could have been a discontinuity in that closed interval, right, that we would have to worry about. Not in this case though. So f prime of x, our derivative. So use the quotient rule. So x minus 1 times 2x minus x squared times 1 all over x minus 1 squared. Cleaning that up, so that's 2x squared minus 2x minus x squared all over x minus 1 squared. So f prime of x is x squared minus 2x over x minus 1 squared. And let's do the algebra, factor what we can out to make our life easier. And so that ends up being x times x minus 2 over x minus 1 squared. All right, so now let's find our critical numbers. So step 1 was the domain, right? Step 2, do the derivative. Step 3, critical numbers. So where is the f prime of x? So f prime undefined. It's never undefined on the interval we care about, right? So if we look at it, it's going to be undefined really whenever x minus 1 squared equals 0, right? So square both sides, so x minus 1 equals 0. So x equals 1, which is not in the domain. And also not in our closed interval, so we don't worry about that. So it's never undefined in our interval we care about. And then on, where is f prime of x equal to 0? Well, that's going to be equal to 0 whenever x times x minus 2 equals 0. So x equals 0 and x equals 2. So those are our two critical numbers in this case. So 0 is also an endpoint, so it's in the interval. 2 is outside the interval. So we don't care about that 2. All right, so then the next step, evaluate our endpoints. So in this case, we have to evaluate f of -3 because it's an endpoint. F of 0 because f of 0 is both an endpoint and a critical number, right? And that was it. So f of -3. Remember, you're plugging this back into the original function, so -3 squared. So f of -3 squared over -3 minus 1. Which then is -9/4. F of 0 is 0 squared over 0 minus 1. So that's just 0 over negative 1, which is 0. So our smallest value in this case is negative 9/4. Our largest value is 0. So that tells us then we have a absolute minimum at negative 3, negative 9/4. And an absolute maximum at 0, 0, 0. And we're finished.